Hello everyone, this is the third session of the Advances in Food Analysis, and we will be studying about the instrumentations and applications of UV visible spectroscopy. So we will be starting with the basics, that is the Bia Lambert Law. Many compounds absorb ultraviolet rays or visible light. The diagram below shows a beam of monochromatic radiation of radiant power P0 directed at a sample solution. Absorption takes place and the beam of radiation leaves the sample has radiant power P. So, Lambert and Boger independently studied the decrease in the intensity of the radiation when it passes through a substance and made the following observations. The amount of monochromatic light absorbed by substance is proportional to the intensity of the incident light. The ratio of the intensity of the transmitted and incident light is constant. The intensity of the transmitted light decreases exponentially when the thickness of the substance through which the light is passing increases linearly. These observations, called Lambert law, can be translated into a mathematical expression as shown below. Log P by P0 is equal to ABC. A is the constant called absorptivity, whose value depends upon the concentration used and is a function of wavelength of the monochromatic light. The concentration is generally expressed in terms of grams per dm cube and B in centimeter. However, if the concentration is expressed in mole per dm cube and B in centimeter, then it is called molar absorptivity. Earlier called molar extinction coefficient and expressed as epsilon. Its units are centimeter inverse, mole inverse, dm cube. The modified expression for the Bia Lambert law is A is equal to log P0 by P. The term log P0 by P is called as absorbance and is represented as A. The expression for Bia Lambert law then becomes log P by P0 is equal to ABC or epsilon BC. Transmittance. What is transmittance now? The absorbance A is related to another term called transmittance, which is defined as the fraction of the incident radiation transmitted by the absorbing medium. Transmittance is equal to P by P0. It is generally expressed as percent transmittance. Instrumentation. Instrumentation for UV visible spectroscopy. The five essential components of UV visible spectroscopy are a stable radiation source, a wavelength selector, a sample holder, and a radiation detector or transducer, and signal processing and output device. Okay. A spectrophotometer is an instrument for measuring the transmittance or absorbance of a material as a function of the wavelength of electromagnetic radiation. Okay, the key components of an electromagnetic spectrophotometer are a source that generates a broad band of electromagnetic radiation, a dispersive device that selects from the broadband radiation of the source of a particular wavelength, a sample area, one or more detectors to measure the intensity of radiation. Okay. So here are the components of the spectrophotometer. That is a source, there is an entrance slit, there is a monochromator. Monochromator consists of two slits and one prism. Okay. Then there is a sample and then there is a detector. Okay. A detector converts a little signal into the electric signal. Ideally, it should have a linear response over the wide range with low noise and high sensitivity. Okay. So types of UV visible spectra. Single beam spectrophotometer. As we can see, this is the flow chart of a single beam spectrophotometer. As the name suggests, these instruments contain a single beam of light. A single beam is used for reading the absorption of the sample as well as reference. Okay. The radiation from the source is passed through a filter or a suitable monochromator to get a band or a monochromatic radiation. It is then passed through the sample and this transmitted radiation is detected by the photodetector. The signals obtained is sent as a readout or is recorded. Double beam spectrophotometer. In double beam spectrophotometer, the radiation coming from the monochromator is split into two beams with the help of a beam splitter. These are passed simultaneously to the reference and the sample cell. The transmitted radiations are detected by the detector and the difference in the signal at all the wavelengths is suitably amplified and sent for the output. Applications of UV visible spectroscopy. Analytical determination of metals and nonmetals, analytical determination of organic compounds, determination of dissociation constants of organic acids and dyes, determination of metal ligands and formation constants, determination of kinetic stability of complexes. Okay. That's all for this session. Thank you.